Okay. Here's a video of me going over some of the stuff on the study guide here. A lot of this material is the stuff that we've been going over in Unit 4 as a whole, right? And all of this stuff is on right triangles. Um, I'm making this study guide or this video for this study guide for you to watch if you're stuck and you don't know how to answer some of the questions. You should not be watching this video just to copy the questions down and do the study guide and get points for it. The point of this video is so that, like, you're doing the study guide and you don't know how to solve the problem, then you watch this video and hopefully, like, watching this video will help you figure it out. But you need to be able to solve these problems on your own for the test. Okay. So a lot of these questions, they're from the book, right? This one is in lesson 7, I believe, where we're given a word problem and we have to just understand the word problem, draw the picture, and use one of our formulas. So it says Mai is visiting Paris to see the Eiffel Tower. She is 80 feet away when she spots it. To see the top, she has to look up at an angle of 85.7 degrees. How tall is the Eiffel Tower? So let's just draw like a little stick figure here. Mai is standing about like 80 feet from the Eiffel Tower, right? I'm just drawing the Eiffel Tower. And she, in order to look at the top, she has to look at an 85.7 degrees. Okay. And we're trying to figure out how tall the Eiffel Tower is. So we need to figure out the length of this side. So we have our diagram. We have our diagram set up. I'm looking at my angle here. And from the formulas that we learned in this chapter, right, we can't use Pythagorean theorem. We need at least two of the sides to solve for Pythagorean theorem. That's to solve using the Pythagorean theorem. We don't have a 45, 45, 90 degrees. We don't have 30, 60, 90 degrees. So we're not using the special right triangles. Excuse me. Instead, we're going to use trig functions here. We have to use either sine, cosine, tangent, one of these three. Right, so let's go back to our study guide. I want to start labeling my three sides. Opposite from the angle is x. Across from the right angle is hypotenuse. And this last side between the angle and the right angle is going to be the adjacent side. And so I'm looking at SOHCAHTOA, right? I'm asking myself now, which two sides am I going to use to set up my ratio and set up my formula? I'm not going to use the hypotenuse, right? Because the hypotenuse side doesn't tell me anything. I'm trying to figure out what the x is going to be, the opposite side. And I know the adjacent side is 80 feet. So I'm not using the hypotenuse. I'm going to use opposite adjacent. Which one of these three has O and A for opposite and adjacent? That's going to be tangent. So we're using tangent here. How do I set up tangent? It's this one, okay? Tangent of the angle is equal to opposite over adjacent. So tangent of the angle is equal to opposite over adjacent. And then it's spelled out here, right? So tangent, I'm going to leave some space here. Tangent of the angle, that's 85.7, equals the opposite side, x, over the adjacent side, 80. I want to solve for x. That's the whole point we're doing this. We're trying to find how tall the Eiffel Tower is. So to solve for x, we have x divided by 80. The opposite of dividing is multiplying, so we're trying to get x by itself. Let's multiply both sides by 80. It's going to cancel out there. It's going to cancel out there. X is equal to, and when I plug in 80, tan 85.7 in my calculator, I get this really long decimal, 1063.965928, and it kind of goes on forever. Let's just round to the nearest whole number. The 10th place is 9, so if I round up, it's going to be 1064 feet. Okay. Okay, let's move on. Let's move on here. So same thing here, number 2, find the missing measurements of the right triangle. It says missing measurements. So when it says that, that means I need to find all of my sides and angles. So what are we missing here? I'm missing AB. What is AB? Let's call it X for now. What is AC? I don't have AC. Let's call that Y. And I'm missing angle B. Let's call that theta. Okay, so I'm just putting variables for each of the stuff that I'm missing. Let's solve for angle B. That one's pretty straightforward. All right, I know all of these 3 angles have to be 180. Right, I know that in a triangle, angle A plus angle B plus angle C, let me put angle C first, have to add up to 180. By now, you should be able to do this in your head, right? Angle A is 27 degrees, angle C is 90 degrees, angle B, we're trying to solve for that right now. 27 plus 90, that's 117. And 117 on both sides, subtract it. You're going to get 63. So angle B is 63. You could have shortened this. By now, we also know we've been working with right triangles. If all of it is 180, and one of our angles is always 90, if we take away 90, 180 minus 90 is 90, right? So that means these two always have to add up to 90. So something plus 90 equals 27. You could do 90 minus 27. That gets you 63. Okay, so you could also solve it like that as well. What about the sides? So now we know that's 63 degrees. So starting from, and then from here, just pick whichever one you want. I was given the 27. So let's use the 27 and start labeling the sides. Opposite, adjacent, hypotenuse. Let's solve for the x first. So if I'm solving for x, I don't need the y right now. I'm only going to use opposite and hypotenuse. So I'm looking at my formulas. I don't even have to go back to the original formula. Again, just spell it out. SOHCAHTOA. Opposite and hypotenuse, O and H, that's sine. So we're going to say sine of 27 degrees equals opposite, which is 12, over hypotenuse, which is x. Remember, there's a shortcut every time when x is on the bottom, when variable is on the bottom, we swap them. That's the shortcut. Okay, so when we do 12 divided by sine of 27, we get about 26.4. Let's round it to the nearest tens place, 26.4. What's really happening though? Why are we swapping it, right? We're just skipping a couple steps. I'm only going to show you this once because we already went over this in class. But basically, we're multiplying x on both sides because we want to get rid of the fraction. That fraction kind of ruins things for us. So now we're left with this. And remember, x times sine 27. So the opposite of multiplying is dividing. So we're going to divide both sides by sine 27. Those cancel out. And notice what happens here. You get x equals 12 over sine 27. Essentially what happened is we swapped the places of x and sine. So that's the shortcut. Instead of like doing all of that math every time, you could just swap them. Let's solve for y. Y is down here. So we're going to do the same thing. We want to use opposite and adjacent because we know what x is, but it's an estimate. So we want to use the two exact values that we have. So let's use opposite and adjacent. SOHCAHTOA. So we're going to use tangent of 27 degrees equals opposite, which is 12, adjacent, which is y. Take a minute. Think about what we're going to do next here. Variables on the bottom. What's our next step? Yeah, we're swapping, right? We're swapping. Okay, so y comes out. 12 tangent of 27. Plug this in. 12 divided by tangent of 27. We're going to get 23.6 if we round it. Okay? So those are our three answers here. I'm going to keep going. Sorry, the PDF version kind of cut off right here, but your packet shouldn't cut off. Your packet is printed out correctly. So it says select all the true equations. Let's look at what we have here. And I'm just going to go through them one at a time. Sine of 27 again. SOHCAHTOA. If you're not understanding the formulas, I'll post this on Schoology so you could look at this while watching this video or something. Okay. So SOHCAHTOA. Sine means you're using opposite and a hypotenuse. So sine of 27 is opposite, which is y over 15. Hypotenuse, opposite, hypotenuse. So this should be y over 15, not this. So this is wrong. What about cosine of 63? Now we're looking at 63. Cosine is adjacent, right, over hypotenuse. So yeah, it should be y over 15. This one's good. What about the next one? Tangent of 27. So we're going back to 27 here. Tangent uses opposite and adjacent. So opposite and adjacent. Yeah, it looks like y over x. So that's good as well. What about sine of 63? Yeah, we're going back to the 63. Sine is opposite over hypotenuse. So that's x over 15. That's good. And then tangent of 63. Again, we're going back to the 63. Tangent is opposite. And this one's adjacent. So it should be x over y, not y over x. So this is wrong. Okay. Just a quick review, right? Select whatever's true. If you understand how to set up the ratios, then you should be able to do this. Okay. What about this one? Here are two triangles. Explain how you know the right triangles are similar. So we have these two triangles, right? How do you know two things are similar? How do you know two triangles are similar? There's one theorem that we learned in class last semester. I want you to think about it. Yeah, AA theorem. So if we can show that two angles in both triangles are congruent to each other, then they are similar. We already know that both of the triangles have the 90-degree angle down here. Right? I see a 90-degree angle here. I see a 90-degree angle here. It also looks like they both have the same theta. So since both triangles have 90 degrees and the same theta, they are similar by AA theorem. AA stands for angle, right? What write a ratio that is equivalent to 5 over x? So this is just a little bit of like a proportions review. 5 over x. Okay, so on the other triangle, since they're similar, you should follow that same pattern. Y over 12. So a ratio that's equivalent, 5 over x is going to be equal to y over 12. Okay, again, they're corresponding. You want to match the corresponding parts. Which ratios of side lengths are equal to tan of theta? So again, let's look at the smaller triangle, tangent is opposite over adjacent. And then on the bigger triangle, opposite over adjacent. So tangent of theta, which ratios of side lengths are equal to tangent of theta? Depending on which triangle you're using, you could say it's going to be 3 over x, or you could also say it's going to be 9 over 12. But 9 over 12 actually gives us a value, so maybe you want to use that. Okay. All right, let's keep going. For number 5, select all true equations. All true equations. So this is the one where, remember in lesson 8, we talked about how the cosine and sine have this relationship where if you have cosine of some angle, it's going to equal to sine of 90 minus whatever that angle is. If you have sine of some angle, cosine is going to be, it's going to be equal to cosine of 90 minus that angle. So I'm going to give a quick example. Cosine of 40 degrees is equal to sine of 90 minus 40 degrees, which is sine of 50 degrees. They have to be equal. Okay? So we're just going to check this rule for each of these choices. Is cosine of 15 equal to sine of 15? No. Right? Because cosine of 15 needs to be equal to sine of 90 minus 15, which is 75. Okay? So that's actually this one right here. So I'm going to check that off. What about B? Is B correct? If cosine is 75, can sine be 15? Absolutely. Absolutely. And then C, think about why C is wrong. It's cosine and cosine. Okay, that doesn't work. Okay. Does it work for tangent? No. So your only two answers are B and D. Write an expression that can be used to find the length of JH, and an expression that can be used to find the length of GJ. So again, I'm looking at my picture. I see a 35-degree angle. And when I look at my formulas, it doesn't tell me anything about using special right triangles or Pythagorean theorem. If it's an obscure angle, if it's like a random angle, just use trig functions. It's your best bet. So let's set it up. From 35 degrees, opposite, hypotenuse, adjacent. Let's find GJ first, right? GJ. So it's going to be, GJ is adjacent over hypotenuse. Let's call this X, let's call this Y. Adjacent over hypotenuse, that's cosine. So cosine of 35 degrees is equal to adjacent over hypotenuse. So then what do we do to solve for X? Multiply both sides by 9. X equals, this is your expression. That's it. Don't plug it in the calculator. Let's do the other one. Let's solve for Y, JH. So opposite over hypotenuse, so that's sine of 35 equals Y over 9. Okay, multiply both sides by 9. These cancel out, so you get Y equals 9 sine 35. That's it. Leave it like that. Those are your expressions. Okay. What about number 7? Sorry, I had to drink some water. Number 7. Find the missing side lengths. Leave your answers as radicals in simplest form. Okay, so this is now going into the other stuff that we learned. I see this triangle, and I see some specific angles here, right? This is also going to be 45 degrees because that adds up to 90. So, okay, I see some very special triangles. We're going to go back to this formula right here. Okay, the legs the legs are equal to each other, right? They're always equal to each other. And then a hypotenuse is going to be whatever the leg is times square root 2. So that's where this formula comes in. Okay, so let's try it out. So I'm going to go ahead and label my sides. This is the hypotenuse, and these are the legs. What did I say earlier about the legs again? They're always equal to each other. So by that, I already know what y is. Boom. 2 square root 2, they're equal. My formula is hypotenuse equals the leg, which is 2 square root 2, times square root of 2. Right? That times square root of 2 is just part of your formula right there. Okay. So I just kind of jumped right into it, right? Instead of hypotenuse, I'm just going to go write x. I don't want to recall the formulas anymore. You should have them memorized by now or written down somewhere. So let's go ahead and simplify here. X is already by itself. I don't have to do anything to the left side. The like terms here are 2 square root of 2 times square root of 2. That's square root of 4. We know square root of 4 is a perfect square. It's going to turn into 2 and just multiply them. That's 4. Okay. What about this one again? Again, this is printed correctly for you, but I don't know, on the PDF it's a little weird. So this one we're using the other special right triangles. So we have to label it short side, long side, hypotenuse. And it comes with these two formulas. So let's go ahead and use those. Hypotenuse always stays the same across from the right angle. We have the long side. Oops, I'm still at school, guys. And then this is the short side. So my first formula, hypotenuse equals short times 2. So that's x equals y times 2. Can I do anything with this formula? No. So I'm just going to go ahead and try to do something with my other formula, okay? The other formula was, so the first formula was this, hypotenuse equals short times 2. The other one is long equals short times root 3. So the long side, it's 10. So I'm going to say 10 equals, the short side is y times root 3. Oh, I could solve for y here, plug it in here, and solve for x. So I'm going to go ahead. Remember, the opposite of multiplying is dividing, and I'm dividing because I want to get y by itself. So those cancel out. Let me write this on the left side. The y is going to equal to 10 square root 3. But what do we say about having a square root at the bottom? Right, it can't happen. So we call this rationalize the denominator. It's part of your simplifying process. Okay, you always simplify. So then the top is going to be 10 root 3. Square root of 3 times square root of 3, square root of 9. That turns into just 3. Can I divide 8 and 3? 8 and 3. 10 and 3? No, it gets a decimal, so we're just going to leave it like that. We know y is 10 square root of 3 over 3. Now this 2, does it get multiplied to the top or the bottom? It gets multiplied to the top, right? And you got to multiply it to the like terms. So this will be your x. Okay. Let's keep going. Number 8. Triangle ABC is equilateral. What is the value of x? What is the measure of angle B? So I'm going to do part B first. In an equilateral triangle, we know that all of these angles are the same, right? All of these angles are the same. And they have to add up to 180. So 60 is our only option. We know angle B is 60 degrees. That's all I'm looking for, really. Now, what about x here? What is the value of x? So, again, equilateral triangle. If this is A, this is also A, and this is also A. Okay? And if the whole thing is A and this line is cutting it in half, this is going to be 4. So let me pull this triangle out. Oh, that's actually kind of crazy. Oops, let me draw that better. Oops, let me draw that better. Okay, so this is 4. This is your right angle, 60 degrees, 8. We're trying to solve for x. Does this look familiar? Yeah, it's a 30, 60, 90 triangle. Okay, so again, short side, long side, hypotenuse. We're trying to solve for the long side, right? Because that's our x. So go ahead and use this formula right here. Long equals short times root 3. Long, so x equals 4 times root 3. That's literally it. Okay, so your answer is 4 square root 3. Okay, keep going, keep going, keep going. This one, we actually did this in class. Whoa, we have so many more. I'm kind of getting tired. Okay, I'm gonna finish this though, because I want you guys to do well on the test. Oh my goodness. If you stuck through this entire video, I'm proud of you. Thank you for your hard work, and I hope you are really taking advantage of these videos. Okay, I'm still at school right now. It's like 5:05. I could be home, chilling, watching TV. But no. A triangle with side lengths 8, 15, and 17 is a right triangle by the converse of the Pythagorean theorem. What are the measures of the two angles, other angles, right? So what is this saying? The converse of the Pythagorean theorem. Pythagorean theorem says in a right triangle, we have a squared plus b squared equals c squared. So the converse means if a squared plus b squared equals c squared is true, then we have a right triangle. So this is a Pythagorean triple. That means these three numbers are going to work for a squared plus b squared equals c squared. So let's just draw the right triangle. Okay, they just kind of gave us the formula here. 8, 15. And remember, the biggest number has to be the hypotenuse, 17. They're asking us, what's the measure of this angle and what's the measure of this angle? So let's just label our sides, A, B, C. Okay, and then let's try to figure out each of the angles. Let's solve for angles. Let's solve for angle B first. It doesn't matter. Okay. When we're solving for the angle, the only formula we can use is Pythagorean theorem. Trig ratios, trig functions, right? Because we have missing angles here. This is the only one we could use. And we learned this the most recently in the last lesson 9. So all you got to do is, again, label your sides, opposite, hypotenuse, adjacent, based on whatever angle you chose, right? If I chose this angle, now this is my opposite, this is my adjacent, and this is my hypotenuse, okay? But that's not the case. We chose that other angle. So I'm going to label my sides, and I have all 3 sides, right? 8, 15, and 17. So when I think about SOHCAHTOA, it doesn't really matter which one I use. I could use all of them. So which one do you want to use? I'm just going to go sine. Doesn't matter. I try the other ones, right? I'll do sine and you do cosine and tangent. Maybe it'll work. Actually, it will work as long as you're doing it correctly. So if I want to use sine, that means sine of theta equals opposite over hypotenuse. So 8 over 17. Remember, all you're really doing is inverse sine on both sides. So that cancels out. That cancels out. and you're left with theta. I'm bringing this to the front because when you punch this in your calculator, you have to do the inverse sign first. So 8 divided by inverse sign, 8 divided by 17. I get about 28 degrees. I'm going to round to the nearest degree. So then we know angle B, we know this is 28. We know this is 28. I know all three angles have to add up to 180, but let's start just thinking about this plus this equals 90, right? So 90, if we do 90 minus 28 degrees, that's going to get us what's left over here. So 90 minus 28, that is 62. Okay, so can I just automatically say angle C is going to be 62? And then 28 is angle B. Okay. Next. Oh, this one we did in class, but if you missed it, I'll just go over it one more time. Let's do this. Equilateral triangle has side length 8 units. What is the area? Ooh, area. I don't know if you guys remember what area means. So, I mean, you should know, but maybe you don't remember the formula. Again, equilateral triangle means that all three sides of the triangle are the same. So 8, 8, 8. Again, our angles all have to be 60 degrees. So when we think about the area formula, area of a triangle is 1/2 times base times height. Where's the base? If you said this 8, that's good, right? That should be our base. Hold up, I'm gonna do this ahead of time. Okay. Where's our height? If you said this side is your height, that is not true. That's a diagonal side. You don't measure your height when you're like kind of slanted forward or slanted backwards. You have to stand straight up, right? So our height is going to be this imaginary line that cuts down the middle. Okay, and let's just call it X for now. If it cuts down the middle, this angle is going to be 30 degrees and this is 90, right? And it cuts down the middle, so what is this side going to be? It's going to be 4. Okay, so the height has to be whatever that X is. You know, let's call it H. We know H. Let's call it H for height. So wait a minute. If I pull this triangle out, doesn't this triangle look kind of familiar? I have 4 down here, 8, 60 degrees, 30 degrees. Oh, that is our 30, 60, 90 triangle. So let's go ahead and label our sides. This is our long, this is our short, and this is our hypotenuse. And I'm trying to figure out what the long side is going to be, the hypotenuse, the height. So I know the formula is long equals short times root 3. Okay. So long is H equals short is 4 times root 3. So the hypotenuse, the height of the triangle is 4 square root 3. So I think we have everything we need for the area. 1/2 times 8 is the base. And then times the height is going to be 4 square root 3, right? 4 square root 3. Okay, 4 square root 3. So let's go ahead and simplify. 1/2 of 8, that's 4, times 4 square root 3. Combine like terms, that's 16 square root 63. So which one is that? Ooh, that's A. Okay. Cool. Cool. Two more. Find the missing side of each triangle. Leave your answers in simplest radical form. This one, I'm looking at my triangle. Do I have any angles? No. Do I have 3 sides? Yeah, and I'm trying to find this one. So this is a Pythagorean theorem. setup. This is x squared plus 8 squared equals 12 squared. 8 squared is 64. 12 squared is 144. Right? Minus 64 on both sides. That's going to be, it should be 80. Right? I'm going to double check. Perfect. And then how do you get rid of the exponent? You square root both sides. That's going to be x square root of 80. Remember, you got to break down the 80. Okay? If you don't know how to do this, watch the other video, simplifying radicals, simplifying square roots. I posted this video a while ago. Break down the 80. I'm just going to pick 8 and 10. Right? Any two numbers. Keep breaking it down. 8 and 10, 4 and 2, 2 and 5. This could be 2 and 2. And, well, I see all of my prime numbers, so I'm just going to skip a couple steps here. I'm going to double them up. I'm going to pair them up. I see 2 2s, so 2 squared. I see another 2 2, so that's another 2 squared. And I see 5 by itself. Remember, when I'm multiplying a bunch of square numbers under the same square root, you could break them up into their own square roots. And why did we pair them up? So that we could cancel these out. So 2 times 2, that's 4 square root 5. So what's the most simple radical form? 4 square root 5. This was on your quiz, right? So this, you should know how to do this by now. Okay, last one. Find the measure of the angle indicated to the nearest degree. So again, we're trying to find the angle, right? If we're trying to solve for the angle, the only one we could use is trig functions. So let's go back in here. Starting from the angle, I'm going to change that to theta. I want you guys to get used to seeing theta. Okay. Opposites is 15. Adjacent, hypotenuse is 17. And then this is adjacent. It doesn't matter. You have all 3 sides. So when I'm using SOHCAHTOA, okay, you could use either one of these. I feel like cosine didn't get enough love in this video, so I'm going to use cosine. But try out the other ones. So cosine of theta equals adjacent over hypotenuse. And we're going to do inverse cosine on both sides. Boom. Goodbye. Boom. Goodbye. So you're left with theta. And then remember, bring this to the front. Punch that in the calculator. You get, I guess, 62 degrees when you round it to the nearest degree. Okay. No excuses. I went over the entire study guide with you. This is stuff that we've been learning in class. You should know how to answer all of these questions on your own. This is it. Okay, so I hope this video helped. Again, you're not watching this video to copy everything down. You're watching this video to use as a resource if you're stuck and you're lost. Okay? All right. Goodbye.